acoustical resonance.
First you, vertically challenged, high frequency squawking alien, you have utterly defeated me with your light amplification by stimulated emission of radiation physics device, or the acronym LASER. You have defeated me.
All right. Thank you, Alan. I'm moving right towards the light, getting closer. Whoa, welcome everybody. Hey, all right, you know what I was doing. I had a few hours free time last night on my hands. All right, well, today, congratulations. You made it through week 1 of virtual school. Well, almost. You have this class. This will be a quick one, only 20 minutes. So what I have here, you can put your mics on now if you want. You had to endure this. Good for you. By the way, first of all, with your wine glasses, if anyone did this last night, remember we were trying to do the challenge, the close encounters of the third kind challenge, and you're trying to get 5 wine glasses, and you're going to try to make that tone, right, with this vibration. Videotape it, send it to me. That's if you want, for extra credit, you can do that. Oh, word blur of the day, which is now unblurred. We know day 1 was what? Online. Day 2 was ellipsis, in honor of Microsoft Teams. Then we had what? Scholars, and now we have Kahoot. I've never done Kahoot, but students are saying they like Kahoot. So my job this weekend is to learn Kahoot. So day 4 is Kahoot. 5 more to go for an ice cream. All right. By the way, what was blocking out my camera was this old finger splint. People dislocate their fingers, stuff like that. So anyway, clearly I'm entertaining myself and no one else. All right. So class is beginning here. You have that close encounters third kind tones if you want. Congratulations again on a great week. All right. What we're going to do today is just 9 problems on this. There's nothing to download. I'm going to turn on the PDF annotator. You see that? The PDF annotator. And we're going to go over the first 3 harmonics of each of the following. The first 3 harmonics of strings, when you have 2 nodes on each end, like a cello or a guitar or a violin. Then we're going to do the first 3 harmonics on open tube, right? You've never done that in a lab. You've done the closed tube. So we're going to do the first 3 harmonics with open tube when you have 2 antinodes on each end. And then we're going to do the last 3 harmonics, of course, with the closed tube, or what kind of wavelengths are hiding and fitting inside each of those tubes and strings, right? And then at the end, we'll do that frequency, beat frequency thing I have show you here. Then I'll treat you as you go with the song I had back when I was a little bit older, maybe like 19 or 20 when they had a song, As You Exit Today, with Thomas Dolby, She Blinded Me with Science. So here we go. Let's start with this. Hey, are you guys there now? Is your microphones on, or am I just talking to myself?
We're here. No, I'm here.
Oh, okay. Yeah, hey, sorry I didn't do that first part. I must have been having an aneurysm last night. So here we go here. Let me share this. I'm going to share my desktop. Okay, share my desktop. Now I'm going to bring up that PDF annotator right now. And now, hopefully, I won't lose you guys. I have to turn my screen around. Sometimes there I am turning my tablet, turning it around. All right, here we go. Tablet on. No. And now I found it easier with my mouse. So you're going to need your calculator and your notebook or a piece of paper here for this, right? Because we're learning how to do quizzes online now too. So let me get a new document. I'm using my mouse now. Get this guy. I'm just learned this yesterday, so just bear with me. This PDF annotator. So you got this. Then get back up here. Do this. So far, so good. Can you guys see this whiteboard now? The PDF annotator.
Yeah.
Okay. Good. Yeah. Excellent. All right, so I'm trying to make this as entertaining and painless as possible for you guys. So let's do this. I got a little my stylus going on right here. And let's begin. Okay, this is going to be super simple, right? It's 15 minutes. and we should be out of here. And then you can go, relax and just chillax for the remainder of the 3-day weekend. And I'll see you next week. By the way, next week, it looks like there's going to be a whole different schedule. Can you see me or no? I'm on the annotator. I don't know if this thing even works. The video on this side. No?
Yeah, we can see you a little bit.
Oh, you can. All right. So sorry about that. My bloodshot eyeballs. Okay, so let's do this. Where's my aluminum inside here? All right, so here's the deal. We're going to start with a guitar string. So we're going to do the first 3 harmonics for that. So let's see if you can see this. So we're starting off figures first. Okay, number 1. So here we have it could be any string, but let's say it's a guitar string, right? So we have a guitar string. If it's a guitar string, you guys know that there's going to be a node on one end and a node on the other end, right? So remember, we're just going to do the 3 harmonics for each thing. So there's going to be 9, well, actually 10 when we do the beat frequency, and that's it. We'll call it a day, right? But I want to go over all the formulae for each. So next week when you do this, it's super simple, right? For which harmonic. So the first 3 harmonics for each one of these. So here's the fundamental tone right here, the first harmonic, right? If it's the first harmonic, we just have a crest or just a trough. So you're going to sketch this nice and neatly like that. So you have a crest and trough. But you look at it, and we're always going to reference points, right? We always use our reference points. We know that this is a wavelength, right? Everyone agrees. So that we know what this part right here, that part is just half, right? Half of a wavelength. It's just the hump part. We know 1 moment later it'll be down where that dashed line is, and it goes. So let's start to figure out what kind of formula we could put in here. Okay, so how many wavelengths are in here? So we're going to go by, we can go by quarters if you want. Like here's 1 quarter and 2 quarters. Sometimes it's easier if you do it. Oh my God, that's coffee talking. 1 quarter, 2 quarter, 3 quarter, 4 quarters, right? So right here we have 2 quarters of a wavelength, 2 quarters of a lambda, right? So this whole distance here, what we're going to do for all these problems coming up, the distance we're going to have of the string or the distance of the pipe, we're all going to have call these 0.70 meters, okay? Now remember, that's not the wavelength, that's just the length of the string, and it'll be the length of the pipe. This is just the length right here, so this will equal the L, the length. Remember, lambda is a little bit different. You have to have a crest and a trough. So let's figure it out. So in this L, as you can see, we have 2 quarters, right? 1 quarter, 2 quarters L, which we know is like 1/2, right? 2 quarters will simplify. And when we multiply each side by 2, right? We multiply this side by 2, they cancel 2. So what do we have on this side? We have lambda equals 2L. Now let's see, does the wavelength equal 2L? Well, we know this. Well, that's just what, half of a wavelength. You guys see it? And we know half of this is 0.7 meters. So the other half must be another 0.7 meters. So it'd be lambda equals 2 times 0.7 meters. And you know that this would be 1 point. And you guys make sure your calculator, you're checking this. I got up at 1 o'clock with this kind of thing and put it all together. I'm a little bleary-eyed right now. So that's 1.4 meters. Now think about that. 1.4 meters. You can know my meter stick. That's like 1.5 meters. That's like 4 feet, right? That's 4 feet right there when you think about that wavelength. Okay. So this would be what's called the first harmonic. And you really just count loops. So it's that whole loop when it goes up and down. They call that and make your life easy. That would be the first harmonic. For example, if you saw something like this, watch. Now, what harmonic would that be? Well, it finished it up with the dash lines, right? Like this, right? And you're just counting the loops, and that would be the harmonic, right? We'll do it neatly up here. So that's the first harmonic right there. But we got to figure out the frequency too. Now, the frequency given, I have to give you this. So it says that it's first harmonic, right? The first harmonic given in here, the first harmonic given. It's kind of, I'm reading off this worksheet that I downloaded off the internet. It's kind of random, right? So the first harmonic, the fundamental frequency is 261. So we know what the frequency is. This is the first, so it must be. So how do you do that mathematically? Well, here is this is your frequency, right? And you put n equals the harmonic, right? And it's just n times the F1. And this F1 here is the fundamental, that's the fundamental frequency. And that would be this one. This would be our word problem. That's the fundamental. So if this is one loop, so we know what the frequency here is. Now watch how much easier it gets. We know this is 261 hertz, right? If this are 2 loops, that would be a 2, right? The second harmonic, 2 loops would be 2 times that, 3 times that, 4 times that. So pretty easy. All right, so let's do the other 2, and then we'll be done with a third of it. Well, in order to get what? We're going to do the first three harmonics. To get the second harmonics, we've got to get two loops. In order to do that, we have two nodes in the first one. So here we go. Oops, come on, hands. I'm kind of holding my hand over this, so it might be a little sloppy. So that's it. So let's double check. We just added a node, right? We had two nodes here in the first one. Now we're going to do three nodes, right? What are nodes in a standing wave? Points of, right? No movement. And so let's finish it. Right? And you can see, I'm not going to circle here and start messing it up, but in this distance, right, given in the word problem, we said that 0.77 meters, right? Or 70 centimeters, same thing, right? And so, but we know, you guys are all smart, you know that this is a complete lambda. How easy is that? You got the crest and the trough. So let's do it in quarters sometimes. It's easier. 1, 2, 3, 4, right? So we have 4 quarters lambdas of a wavelength in the L here. This length is the L, right? Right there. So 4 is 1. So in this case, what? Lambda equals L. So what is the wavelength for this one? This one is exactly what it says. It's 0.7 meters, 0.7 meters. So let's figure out the frequency, right? Well, the frequency, right, what number? This is going to be number 2, right? And here, I'm going to mess it up. Now, there's the first harmonic, and there's the second harmonic, right? The 2 equals, right, N times the fundamental. Well, let's see. What is N? This is the second, and the fundamental was 261 hertz. So someone quickly do that. That would be what? 522, right? So this would be, the answer would be 5. This would be 522 hertz, right? That would be, we just multiplied this by 2 in the second harmonic. All right, third one. All right, third one right here. So in our third harmonic, right? Yeah, we had 2 nodes, 3 nodes. Now, yep, you guessed that we're going to have 4 nodes. So let's put 1 on each side as usual. And 1 here and 1 here. Then kind of carefully, your notes should be a lot better than this when you email them to me, so I know you did this. And you go like this, blah, 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 blah. Right, so there you go. Now look, there's 3 loops. So you know this must be the third harmonic. The third harmonic. I'm just teasing about emailing notes. You can take a deep breath, those people. All right. Okay, here we go. Now we have this. We know the same thing. It's 1.7 meters, right? But let's count. We can do quarters or halves. It doesn't matter. Let's do the quarters since we started here. 1 quarter, 2 quarter, 3 quarter, 4 quarter, 5 quarter, 6 quarters. Right? You have to bear with me on my handwriting here because I'm just holding my hand above the screen because when I touch it, it's setting off all these buttons and executing things. All right, so wait, what did we just say? There's 6 quarters wavelengths, right? In this L. Remember, this is the L. This is the length of this string, right? It hasn't changed. It's the same thing. So let's just simplify, right? 3, 2. Now let's move the 2 and the 3 over here. Sorry, multiply each side by 2, divide each side by 3. And so what do we have? Lambda equals what? 2 thirds L. So when we do it, and we know L is what? 0.7. Well, what is 2 times 0.7 divided by 3? Right? We should get 0.47. 0.47 meters. That makes sense, right? As what? Wavelength is going down here, right? Wavelength's going down. Frequency has to go up. Let's see if that's true, right? So frequency on the third harmonic equals N, right? N F1. So that would be, we're on our third harmonic. Simply times what? The fundamental though, right? Don't go by the second one, 261 hertz. So what is 261 times 3? You should have what? That should be 700 and, if you're pushing your buttons, 83 hertz. So there's, how easy is this question? So we have our first, second, and then look, we know this is our third because there's 3 loops. 3 loops in there. All right, so we're done with the string. Now we're going to do open tube, and then we'll do closed tube, and we'll call it a day. All right? Okay, let me see if I can put my hand on here again. All right, so here we go. Now we're going to do open tube. Open tube, right? Open tube. Which means we have what? We have a tube is going to look like this. And we have 2 antinodes because we know that there's an antinode on an open tube. No matter what kind of tube we use, if it's an open end, that's an antinode that's going to lay up there. Right, so let's do it. We're going to do what? We're going to do the first, and we're going to use the same length, right? So here, now watch, we're going to use the same length here. We're going to use 0.7 meters, or what, 70 centimeters for this whole length of the tube, right? So we're going to get the first harmonic, the second harmonic, and the third harmonic. Oh, by the way, I think I forgot to do this on the first one. Let's just figure out a formula for this so you can quickly check this out. We can quickly figure this whole thing out. And the first one, what do we have? We had 1/2, right? And then we had 2 halves. And then we had 3 halves, right? So if we had 1/2, and then we had 2 halves, and then we had 3 halves, what can we figure out here? We can just figure out that the lambda, here, I'm going to make it a little neater. Then I'm going to move these things up. Lambda, if you want to just do it in your notes, super easy, we can make a formula, right? The lambda of n, whatever harmonic it is just going to be 2 times the length of the string over n, over whatever harmonic. And this is going to be the same for this guy. That would be our formula we can use. Let's just double check it right here, right? If this was 1, oh, yep. If that was our first one, 2L divided by 1 is 2L, and it is 2L, right? This one, 2, 2, up, 2 over 2. Yep, lambda equals L, or 2 over 2, and the same thing over here. Okay, so let's go. These are the open tubes. I'm going to kind of do this a little more neatly here. Let's do the first harmonic for this guy, right? So first harmonic. Now, again, I'm going to sketch this a little bit better. Here's our tube like this, and I don't know why it just vanished. Okay, and it just vanished again. Let's hold it like that. All right, so here we know the length of this is going to be 0.7 meters, right? Just like for the rest of this whole, and then the closed tube, everything's 0.7 meters, right? Okay, so 0.7 meters. So we want to figure out, we know, let's just do our It's our wave at rest, right? Nothing's moving, no air is moving. So if we're doing our first harmonic, it has one node. And that's it. Now we have 2 open ends. So we have to start from an open end, right, as an antinode. Then we have to end at an antinode. So let's do the opposite where it's going to be 2 seconds later, like that, right? So now look, let's think about this in quarters. And you guys all know when we use like our reference like this, that's starting up here, right? That's starting up here and ending down here. Well, that's a half of a wavelength, right? That's 2 quarters. Here's a quarter, and there's a quarter. So that's 2 quarters lambdas in this L. In this, that's an equal sign. L. Well, let's just simplify that. We'll make that what? 1/2. And so again, with this first one here, what is it? We know that lambda, and we're going to figure out a formula for this with n in a minute, right, is 2L. Well, that makes sense, right? So right here, if we have half of a wavelength right here, we need another half, right? So if half of the wavelength is 0.7 meters, to get the full wavelength, that must be what? 2 times 0.7 meters. So that's pretty easy right there. Now, and in fact, we're not going to do the frequency with this. It's having a hard time writing this stuff. It's pretty easy. Once we find the speed of sound, we'll just say it's like 343, right? So then you'll have what? Velocity equals frequency times wavelength. So whatever velocity, we figure it out, if it's in air or whatever the velocity is. Hey, guess what we know? We know the wavelength. So say, just for example, that was 340 meters per second, right? Equals, if we're solving for frequency, we know what the wavelength is. And you guys know we just going to divide the wavelength into that to get frequency. So that's just how you do it. All right, so let's get into the second. All right, let's get into the second harmonic. The second harmonic here, open tube, second harmonic. Okay, so here's an open tube. So we know we're going to have what? Antinodes on each side. All right, let's draw the wave at rest. Oh, but we had 1 node in the first one. So this must be what? 2 nodes. And remember, it's easy to sketch. The more you sketch these, the easier it's going to be. You'll fly through the evaluation, right? So here's an open end, right? So here's an open end. So it goes through the node, press, back through the node. Oh, look, we're in an open end over here, right? So we make sure that's an antinode. Let's do the opposite one. Will be 1 moment later, then we'll count quarters, right, again? So this first one, there's 1 quarter. Let's split this guy, right? 2 quarters, 3 quarters, right? And that would be what? 4 quarters. Well, you guys knew from 8th grade, even crest to crest or from trough to trough, right? If you go crest to crest, that is a wavelength. So let's check it out. Let's write it up. So we have what? 4 quarters. So we have 4 quarters wavelengths, right? In this L, right? In this length of pipe. Right? So if that was 1 meter, it'd be 1. Doesn't that make sense, right? Because we've accommodated all. We've got our crests and we've got our trough. We did 1 complete wavelength right there. So lambda, right? Or L would equal lambda, and lambda would equal L. Not so hard. Okay. So far, so good. So what would this one be? If we know that the length of this pipe is 0.7 meters, right? That would be this length of pipe, 0.7 meters, right? So lambda equals lambda would equal 0.7 meters. All right, so far so good. And we're almost a third of the way done for the day. And then you can go chill. All right, so here, let's try this one here. We know we're going to make the third harmonic. The third harmonic. We had the first harmonic, the second harmonic. Now we're on the third harmonic. Now this funky end over here, remember that's another open. Ooh, that looks weird. All right, so draw your wave at rest. And we had one node. Now we had two nodes. Now we have three nodes. So it's probably always easier to put a node in the middle and split the difference on each side, so it's somewhat like organized. Two open ends again. So we have an antinode starting here. So the antinode, and we swing down here, and then we have a node. There's our cross through the node and the antinode. And hold on. This is an antinode, right? Because we're ending at pipe. And so a moment later, here we go. It's going to be up here as this oscillates in the standing wave, right? All right, let's count quarters, right? Here's one. We split this, right? There's 2, 3, right? Here's 4, 5, and 6. So there's 6 quarter lambdas in this length, right? In this length right here. 3. And we know what the length is, right? Because we said for all these, the length is going to be 0.7 meters, right? So let's do it. Well, we're going to simplify this a little bit here. So if this 3 halves, remember this first one we had 1 half, and right? In the second one we had 2 halves, and now we're at 3 halves, and you can figure out there's a pattern going on in 4 halves, 5 halves. So let's just multiply each side by 2, right, and divide each side by 3. So what do we figure out? We can figure out what the wavelength is here. The wavelength, right? We multiply by 2, divide by 3. So it's going to be the inverse, right? 2/3 L. Well, wait, we can kind of see what's going on here, right? The first one we had what? We had 1 half, right? So we had 2L, we had the lambda equals, right, 2L over the n, right? 1, it was 2L. And this one we had 2 over 2, and now we have 2 over 3. So our formula is the exact same as the one for the string right here, for the open pipe. Not the same. Well, we'll see in a second. So what's the answer to this? Let's just put in L, which is 0.7. So if you do that, 2 times 0.7, if we divide it by 3, for this guy, you should get 0.47 meters. 0.47, you shall be bobbing your head and congratulating yourself like that. All right, we're done. We are done with open tubes. So you should know how to do 3 harmonics for that, 3 harmonics for that. Now we're going to do the closed tube, which you've kind of done before when you did the speed of sound, right? So let's do it. Let's do closed tube, right? Oh, wait, I should say one end closed tube, right? One end closed tube, right? So here you have, we'll call that the closed end, and here comes the pipe, right? Just like what you guys did with but you guys held it vertically instead, right? But we know the node on a closed end, right? Whatever it is, right? If this was some of those people like hoarding toilet paper and they put a cardboard end on here, those bunch of weirdos, right here, and then that would be this right here. Here's your wave at rest, right? But we have a node here. And look, we have an open end, right? Over here, we have an open end. We'll call this closed end. I'm trying to just hover my hand over. Now, if we have a closed end, we know the node's always there. It's easy. Anytime we have a closed end, the node's in the middle. And we have an open end, and that's always an antinode. So here we have a node and an antinode, so it's simply that. And one moment later, it'll fluctuate back down, there, right? And that's just 1 quarter, right? That's just 1 quarter. That's just 1 quarter. So what do we have here? We're going to have, there's only 1 quarter of a lambda in this L. In this L, right? In this L. That's why when we solve it, multiply each side by 4. That's why when you guys did that lab, you multiplied by 4, right? So you multiplied by 4 to get that. And since all these are exactly, it's getting a little sloppy here. So remember our pipe right here. For all, why does it do that? All right. Let's write it down here. Doesn't seem to like it up there. So in our pipe, we know all our pipes are what? 70 centimeters or 0.70 meters, right? The string was 70 centimeters or 0.7 meters. The open tube was 0.70 meters or 70 centimeters. And this is, so We know what the L is, so it's simply, what is the lambda on this then? It's 4 times 0.7 meters, right? So what would that be, right? That would be what, 2.8 meters, right? So lambda equals 2. That's like the distance from the floor to the basketball rim almost. Think about that. That's a long meters, right? Meters. That's a big lambda. All right, so that's the first harmonic, right, with one node. Here's closed pipe number, well, one unclosed pipe number 2, right? So you guys get it. If we had, here it is right here. Here's our closed end. So there's the node, right? So let's go through there. But this isn't just one node. We just have, this is the second harmonic. Oh, my bad. No, this is not the second. You'll see, because it's a closed tube, these are only odd harmonics. And we don't call it the second one, even though it's the next harmonic up. We call this one the third harmonic. And this next one over here will be the fifth harmonic. Now watch, we'll figure it out. Right, so here's one node and here's another node, right? We'll put the other node right there. So up, we're start at a node. So let's go up. We have a crest and we have to come back to the node. But hey, there's no other node to go to. So we have to end. There's no node up right here in the middle. So we have to end in a what? This is an open end. So we have to end as an antinode. Let's show how this one's not as good, but you guys get the idea, right? Like this. So there, and that's fluctuating around. So let's see if I can separate this. Here's 1, 2, and 3/4, right? Let's think about that. There's 3/4 lambda in this L, in this length, right? Not quite 4/4, right? Not quite so it's 3/4 lambda in this L, right? And we know what the L is, right? We know the L, we said it was 0.7 meters, right? So let's do it. Let's first of all solve for lambda. Lambda equals what? 4/3 the reciprocal here, right? Right. You need a little more. You need a little boost it up, right? Because it's only 3/4 of the lambda. So in order to get the wavelength, you got to get that extra little quarter in. So let's do it. And so once you do that L, you multiply it by 0.7 meters, right? So now we should all figure it out. That lambda equals, well, what are we going to do for this guy here? It should be 0.93 meters. Makes sense. Is 0.93 meters. We know that wavelength's got to be going down, right? So frequency has to be going up. All right, and the last one, well, we had one node, we have 2 nodes, so you guys can figure it out. And this, we're going to have, let's put this, here's the closed end, right? Here's the closed end, and here's the open end. If it's an open end, we know it's an antinode. Closed end, it has the node right there. So let's draw the wave at rest, right? But not 1, not 2, but 3. Right, we have to have 3 nodes, 3 points of 0 displacement in this standing wave. So let's begin over here. We'll get the crest, and then we get the trough, and then we get a crest, right? So let's I'm getting all hung up here with my stylus. All right, so let's see. Here we have 1, 2, right? 3, 4, 5, right? So in this, and we know, I didn't go 1 minute later, it's going to go by like 1 second later, it's going to be like that, right? So what do we have? We have 5/4 lambdas, and you should definitely get a good understanding what's going on here in this length, And we know this length, again, for everything, it's 0.7 meters, right? 0.7, that's 0.7 meters. Let's do it. Let's solve this one for lambda, right? So I'll solve for lambda. Take the inverse again. So we had 5/4. So this is what? 4/5 L, right? 4/5 L. So when we do this, let's check it right, because there's more. Here's one wavelength right here. Here's one wavelength, right? Crest and trough. So there's too much in here. So we got to kind of shave off a fifth, right? That's what this math problem does right here. So when we do lambda equals 4/5 L and 0.7 meters right here, and you do the math on this, and you should get, let's see, what did I get on this one here? 0.56, right? So lambda equals 0.56 meters, right? Okay, almost on one last thing. So that's it. You can see what's happening here as wavelength decreases and the frequency would go up. We could prove that. And the last thing, I just want to remember the beat frequency, F beats. I'm trying to give you all the formula. Equals what? And the harmonic, right, times the fundamental frequency, like we did the first one. So again, completely my bad here. Pretend you didn't see that. I've been up since 1. F beats is what you take the higher frequency, your F higher, and you subtract your what? F lower from it. So you have, like, for example, in our school bell, if it's 517 hertz, right? Minus, I don't know, 515. If I played two tones simultaneously, these two guys, right? Well, the difference between them is 2. And that's it. What? 2 hertz, 2 beats per second, or 2 woo-woos like we did in class. 2 woo. So that's the formula for beat frequency. So you write like beat frequency formula for that guy there. Other than that, thanks for putting up with me in the beginning. You guys have been great. You guys make it easy. Everyone's been here every day. I just had one absentee out of all the classes all week. So enjoy. Have a great weekend, and get out to some fresh air. And hopefully I'll see you on the 30th. But I'll definitely see you Monday on our new schedule that school's going to have. So stay tuned. We'll email you with the new schedule coming out. All half days. Taylor, you're going to like that one. All right. So take care.
Thank you, Mr. Fletcher.
You're welcome.
Yeah.
You're welcome.
Thank you.
You're welcome. Have a good day. See if I get out of here. Let's see. Stop resenting.